everyone. Welcome to our Symbol community meeting for the month of June. I'd like to welcome everyone here today. Today's date is Wednesday, June 28th, 2023. If you are watching this recording from home, we encourage you to come in and join us live. As a reminder, these community meetings are public and recorded and posted to YouTube at the conclusion of the meeting. This meeting's for you, the community, so you're encouraged to bring up any discussion topics, ideas, anything you need help with relating to Symbol, AI, ML related stuff. So yeah, just any kind of topic, conversation intelligence related, anything like that, generative AI, all that stuff. If you have any discussion topics that you want to bring up today, you can scroll down here and add them to the agenda, and we can get them towards the end of this meeting. For those on the call today, you're welcome to add your name and organization to the list here. And it definitely isn't required, just kind of gives us an idea of who is interested in the platform and the sessions that we're holding. So let's go ahead and kick this off and talk about announcements. So materials for the month of May, it's the May community meeting. You can find the recording and the slides here. The YouTube link is available and the slides are also posted there. So you can go ahead and take a look at the slides and click all the links that were embedded in the slides. Some additional community repo updates. I had hoped to post the topic or the training videos for the next 3 topics, which is topics. The next one would be questions, follow-ups, action items, and then the last one's entities. We planned on posting them before this meeting, but we kind of had decided to change things up, and we're going to have a blog post kind of wrapping each one of those. I think the first one topic should be released, I hope, this week, maybe next week. And then you should hopefully see one per week kind of going forward. The next set I'm working on is sentiment analysis, and the one after that will be trackers and then bookmarks. Any questions there? All right, if not, so the updates from the last meeting, we didn't have any action items, and I think with that, unless there's any other questions or anything like that, we're going to jump into the presentation today, which is generative AI and agents. All right, so today's topic is large language models and autonomous AI agents. Obviously, the topic is scorching hot right now, and most people are kind of getting familiar with LLMs. However, I think there's still a gap in like just general generative AI or autonomous agents, and especially the autonomous agents area is kind of something that's kind of yet still to be discovered. So kind of the point of today's session. So for the agenda, we're going to initially talk about what LLMs are, and then we're going to discuss generative AI and autonomous agents. Next, we'll discuss some use cases for these generative AI agents, because I think they're kind of more of like an unknown. We're kind of all familiar with LLMs and like chatbots and ChatGPT and kind of like what they do for us, but generative AI agents and autonomous agents are kind of more of an unknown. And I'll have a few demos spread out through the presentation, and then we'll have some resources and some Q&A at the end. So what are large language models? We've been hearing the term quite a bit these days. For those people that aren't in the non-technical field, a lot of people associate AI or generative AI or LLMs or agents by default with ChatGPT these days. For a lot of us, we know that there are many other LLMs or large language models out there. So let's go ahead and talk about some of them right now. So large language models is an algorithm kind of that uses deep learning techniques and massively large data sets. We typically use artificial intelligence to encapsulate that concept. Well, kind of more simply than that, they're effectively kind of like next word or next token prediction engines. Effectively, you have prompts and you have questions being asked. It goes and searches through its data set, and it tries to figure out what the highest probability or next thing to as a reply or response is going to be in a conversation. And so that's kind of like how LLMs work. So it's the machine learning's attempt to predict like what the output is with the highest degree of like satisfaction of like the result of what we're interested in. So interestingly enough, like that kind of definition is kind of like really kind of weirdly vague. There really isn't any more kind of a formal definition outside of like what I've kind of given you. There isn't a definition of what large in a large language model is. And the language model doesn't have to be language based. It could also be geared towards like video and audio and other media. In general, LLMs have like large data sets of information that they contain. They take in input from the user in the form of a prompt, and they kind of perform pattern recognition and like clustering of data in order to like discover patterns to predict the next token or the next thing as to say as a response. So this also entails like neural network performing data labeling and classification, and while it's ingesting all of this data that it needs to like classify or and provide like metadata and labeling when it's consuming all of this data that's being thrown at it. So some definitions and terminology that you might want to be familiar with. You have the data sets or training sets. So this is basically like the raw information that is being consumed. So this is like when you hear like ChatGPT using like Wikipedia, publicly available sources of information like books and these collections or libraries, books, those are the things that are being talked about when they're talking about like training sets, or like this is effectively kind of like the raw information. The next thing you'll hear a lot about is model size. So model size generally refers to the amount of memory required to store the model's parameters and associated like components. So model size is typically used to measure the total number of bytes required to store the entire model. And then another term you might hear is parameter size. Parameter size typically refers to the number of parameters or weights in the model. So like in the case of LLMs, parameters are like the learnable components or the associations that the model uses to make the predictions and also generate the text. So just as a side note, if anyone is kind of asking, so model size and parameter size are somewhat related. So like the model size takes into account not only the parameters, but also other components such as like the embedding, activation functions, anything, various layer modules and stuff that make up the model, like whatever, all these extra things like configuration, and that also is inclusive of like what the model size is. And then another thing you might be here is token. So token is just an individual words, characters, even subwords, depending on like what the model does. It could be a variety of different things, image-based models. It could be like individual sprites. So it really just depends on like what the model is. And when we talk about like training models, so like how do we improve the accuracy of the model? So like what the percentage is of how accurate or like what the outcome is. There's really kind of two ways of doing that currently, like two major ways of doing that currently. So there's like a self-supervised, which means that the model learns from unlabeled data without kind of having external supervision. So that's that self-supervised learning. So there isn't any kind of external explicit supervision or like labeled examples. So the model kind of like learns to predict the next word in a sentence, or fill in masked out words based on like surrounding context. And then the second method is like semi-supervised. So OpenAI initially started out doing this, and they still do this to this day. My understanding is that they have inputs of data sets that have already been pre-labeled, and that basically further enhances the accuracy of the model. So this is done usually by like another system or by humans saying like this is that, or this is a good behavior and this is a bad behavior. So let's talk about like obviously one of the more popular LLMs out there. So that's ChatGPT. It's created by OpenAI. So GPT stands for Generative Pre-trained Transformer. So they're kind of the two varieties of LLMs that you hear these days are GPT-4 and then 3.5. So like what makes kind of GPT-4 kind of really unique is that it's was trained on like 45 gigs of training data. There are 1 trillion parameters involved in this model. The GPT-4 is, interestingly enough, is multimodal. So you can also provide image input and output in GPT-4. There is a beta feature that you have to enable. It's not enabled by default. That also allows the model to go out and access the internet. So it kind of bridges the gap between the lag in how relevant or how recent the data is. There's I think, what is it? ChatGPT is only it's like kind of like roughly about like a year and a half ish behind in the data that it's being fed in, so it doesn't contain current events. And so enabling that feature kind of helps bridge that gap. And GPT-4 has kind of been quoted as being more reliable in the predictability or the responses that it gives to its users. And then just kind of as a reference, the delta between 3.5 and 4. 3.5 was done on 17 gigs of training data with 175 billion parameters. It's a text only input and prone to hallucinations. But kind of like the big takeaway, I think, is for GPT-4 is the fourth bullet point, that it's you have human level benchmarks where it's able to pass things like the bar exam that lawyers take. So as an example of like what these human benchmarks are, that it can pass the bar with at 90%, the LSAT at 88%, and the GRE quantitative is 80%, and the verbal's 99%, which is pretty interesting. And then the last part, I still think it's somewhat still relevant in for GPT-4, but even though 3.5 is prone to hallucinations, I think you should still definitely take the results that come out of GPT-4 with a grain of salt. If in your prompts, you should definitely say that if instruct your chat with the directives with the prompt saying that if you're unsure of the answer, it's okay to say you don't know, because a lot of the times if you don't put that in there, like the model will just spit out an answer even though it might not be true. So let's talk about a different large language model. So there's one called Llama. It's by Meta or Facebook. Basically stands for Large Language Model Meta AI. Interestingly enough, the Llama model was leaked in a GitHub PR. And I have the link there if anyone's kind of interested in seeing that, and like why. And if you want access to the Llama model, you should technically go to Meta's Llama page and apply for access to the model. But if you happen to look at the PR and you look at the magnet link for a BitTorrent, you can actually download the model in all of its packaging, which includes the 65 billion, 33 billion, 13 billion, and 7 billion parameter models. They're all included in there. And they have a 1.2 trillion tokens in the models. So if you happen to drop that magnet link into Torrent, it will take some time because it's a lot of data that you're downloading. It's like on the order of multiple hundreds of gigs of data that you have to download, but the torrent will work. Don't say I didn't say to do this, but it's just out there. I'm just floating it. So the idea for Llama was kind of to create smaller models and provide more training data to the neural network, as opposed to the opposite of kind of like what it's done is to have larger models and then, use training data as verification. And Facebook's idea was to flip it, kind of smaller models and more training data. And because of that, it requires less compute and less memory to run. And in fact, the 7 billion parameter model for Llama can run on a Raspberry Pi. So you also might see a variation of this called Lima, which is a very narrowed down version of Llama. So it's a very specific version, and it was kind of pared down to be effective in only 1,000 prompts. And also you might have seen Alpaca 7B, which is kind of a fine-tuned version of the Llama 7B model, so the 7 billion parameter model. The Alpaca 7B was generated or tuned by the people at Stanford. And the claim is that it's just as good as GPT 3.5 using the Text DaVinci 003 model. So if we kind of do a comparison between like Llama and ChatGPT, you'll see a lot of people doing this model versus that model. My personal feeling, it's not an either or choice, but maybe like a both or all kind of choice when it comes to like models. Some interesting facts that the Alpaca model was actually trained by OpenAI's ChatGPT 3. So the Stanford model Alpaca was actually trained by another AI. So the ChatGPT 3 model, which is kind of interesting. So if you're kind of interested in those details, I've provided a link here and you can learn more about like how that came about. There's also an interesting white paper called Self-Instruct, which kind of goes over the algorithms on how this actually happens, how you use one model to train another model. I kind of want to talk about this a little bit more because I think it's like very interesting that you're using one AI model to train another. The whole Alpaca 7B the whole point of Stanford for doing this was to reduce the cost of training models. And so they were able to use GPT 3.5 to train Llama to be more efficient without using hardware graphic accelerators like NVIDIA cards. They were able to do this to the tune of only $600, which is far, far less than the power cooling and graphics card needed to train very highly effective LLM like Alpaca. It's kind of interesting that you use one model to train another. It's kind of like this weird, once a compiler gets to a certain point, you can use the compiler to make the compiler. It's very true in this case too. And you can have not only that, but because we're talking about AIs, not only using the compiler to compile the compiler, but you're also, because you're using AI, you can also enhance the ability or the effectiveness of the compiler in this case, right? So it's kind of really cool and kind of an interesting concept. Kind of, if you do a comparison between ChatGPT and Llama, the major strengths of GPT-4 is that it's obviously like a SaaS platform. You use an API to access it. It's API driven, easy to consume. And that's kind of like the biggest reason of why you want to use GPT-4. You don't need to train a model. It's kind of already provided. You just use an API and boom, you're off and running. So for Llama and Alpaca, you can run the biggest advantage is you can run locally. And because you can run it locally, you can run it anywhere. But there currently isn't an API for it. I'm sure that's probably going to change fairly soon. That doesn't mean you couldn't make one as a way to interface to the model. So the other interesting thing is that because you're running it locally, you're also taking on the responsibility of any kind of future training or maintenance of the model, or you're relying on others to do that for you. Kind of similar to the OpenAI case, you're obviously relying on other people's because it's a SaaS platform, but there's incentive for them to do that because they're getting paid, or at least there's being money being thrown at them in the form of Microsoft money or whatever. But in the Llama and Alpaca case, especially with some of these like Alpaca and some of these other models, you're more relying on like communities kind of support for enhancements and improvements to the model. So I'm going to stop there. Have any other questions? And if not, I'm going to have a small demo. So we're going to do a demo for Llama. Let me see if I can share my console. Alrighty, hopefully everyone can see my console here. So my demo here is I'm going to effectively run Llama locally, and I'm going to use the 7B model because it's the smallest one so that we can reduce the amount of time it takes to bootstrap everything. But I think this is a really kind of a cool demo to kind of showcase running LLM locally instead of relying on something like ChatGPT or OpenAI. Don't need to write any of these commands down. I'll have that available at the end in the slides at the end. Also links on like how you can reproduce all of this. I'm going to skip over a lot of the setup steps that were required because I'm running this on a Mac, so that I had to install the developments, Mac development stuff that I'm assuming that's already installed. I'm definitely assuming Brew and package config and CMaker installed. I did the appropriate stuff to install any kind of prerequisites just so we can skip over that. And so for Llama, what we're going to need to do is, let me first start documents. I'm going to first clone the Llama repo. And I'm using Llama CPP because it's just, for me, the easiest thing to do running locally. It's Llama CPP is effectively like a bootstrapper for running Llama locally. And we're going to go ahead and do that now. So I'm going to just clone that out. And then I'm going to go into the directory. And then I'm going to install any of the requirements that the repo has. And then I'm just going to run a simple make command. Finished. We're going to go into the models directory. There's a model already here. I'm just going to remove it just so that there isn't any confusion. And then the next thing I'm going to do is copy the Llama 7B model to the models directory here. So let's go ahead and do that now. So while that's copying, I'm also going to need to copy the tokenizer model and the checklist. So All right, and then if I do an ls on the models, I can see all that stuff is there. Excellent. Whoa. The next thing I'm going to do is I'm going to run this convert script. So this allows me to convert the model to the ggml format. So it's just a different format for the model that I can consume locally. And I can do that using this Python script that's available in the repo here, which is named convert Python to ggml. Right here, Pat. And so I'm going to go ahead and run that now. So now it's converting that. The next thing I'm going to do after this, it's going to take a little bit of time, is quantize the model. So this is basically putting it into the byte size that I need it to be. And I'm going to go ahead and do that. And there's basically, when we did the make command, there is a application that got created as a result of that. That's quantized. So we're going to go ahead and run that now with some parameters to put the model into a different format. And once that is done, you can see that it's there. So we should have now, at the conclusion of this, we should see this right here, this GGM model Q4 bin. And we're going to go ahead and now there's a script that now wraps all of this stuff, and it's under examples. It's this chat script here, which effectively just takes the application, this Bootstrap application, takes the model and then loads it into a chat style thing. So we can go ahead and run that now. And it's going to go ahead and load the model. So the GGLM model Q4_0. And you can see the prompt here, right? So it's basically saying, hello, Bob. Hello, how are you? Tell me about California. So, just like ChatGPT, right? So, but the cool thing about this is that it's running locally, and we're not connected to the internet. It's running this all based on like what's on my laptop. The interesting thing is, if you want a more powerful model, you can obviously use the larger models that are included in Llama, do the exact same steps instead of using the 7B. And you can get a more powerful, more robust model that's kind of comparable to like ChatGPT. Then if you have any questions, feel free to drop me a line, but let's go ahead and get back to the presentation. Okay, so I hope you enjoyed the demo. Now we're going to talk about generative AI agents or autonomous agents. So what are generative AI agents or autonomous agents? They're effectively AIs that can solve problems on their own. They don't require any human prompting. They're able to create, finish, and prioritize tasks on their own. They are self-learning and refining. So it's basically everything you'd think about an AI needing in order to be autonomous. So the key components for an autonomous AI agent or an autonomous agent is that you have obviously the AI itself. So meaning you have some sort of LLM or model to crunch the input and provide output. These are things like we had just talked about, like GPT-4 or Llama or Alpaca. And the next thing you need is to have a form of memory of the agent. So this usually takes place in the form of a vector database. And the reason why this is important, because you want to avoid repeating the same tasks over and over again. If the LLM sees it performing the same task, instead of repeating and crunching and processing that same task, you can just reference the output of that task. Provides memory, right? It provides the ability to remember what it's done. And then obviously take that information and take the output of that and feed that into the output, the final output of the task. And then finally, there's usually some wrapper or glue code to hook the AI or an LLM to its memory. So there are a whole bunch of projects out there like LangChain, which is kind of effectively like an LLM wrapper. There are kind of two projects that initially got a lot of press out there on the onset of AI agents. They were Baby AGI and AutoGPT. These days, there are over 10 and probably at this point now over 20 plus AI agents or autonomous agents in the ecosystem. Here's a link to look at all of the various variations of these agents and what their strengths and weaknesses are and like what they're trained to do. So I thought since Baby AGI and AutoGPT are kind of were the first initial projects to get a lot of notoriety, I thought I'd be good to compare and contrast these different architectures and implementations. We do a comparison. So like Baby AGI, the biggest draw is that you can run your autonomous agent locally because it supports local LLMs. The architecture is very much task list driven. So this means that you can kind of give Baby AGI an initial task. When you give it the initial task, it creates subtasks and subtasks and subtasks. And when there are no more tasks, that's when the answer is available. So Baby AGI under the cover uses a vector database. So you can use something like Pinecone or Chroma. So like Chroma is like an in-memory kind of thing that's really interesting and cool. And the other very interesting thing is because you're using like Pinecone or Chroma, Baby AGI is you have all of its memory related to the particular tasks. Because everything's persisted, it won't drift from that end goal. And so that you can refine the tasks, create more tasks for better results. So you can refine the output or the answer for individual given tasks to refine the output for a given overall, the larger task that you provided. So then in comparison for AutoGPT, as the name implies, it uses OpenAI's API. So you can use GPT-4 or 3.5 for the memory component or how it remembers like what it's done, like the tasks that it performed, is that it leverages OpenAI's memory model in the platform. So it's kind of all just leveraging what OpenAI has created. And since it's using GPT-4, you have access to other resources out there like images. And, if you enable the functionality, there is the ability to go out and access the internet, which is kind of a good, huge thing for AutoGPT. I think that probably, if not, it's the biggest strength that it has. Obviously AutoGPT, ChatGPT, it shines when you're trying to generate like human-based content. So these are things like blogs, papers, and whatnot. So now that we've kind of taken a look at the different types of generative AI or autonomous agents, let's go ahead and take a look at some of the use cases for them. Why is this different? Why are we talking about this? Why are we making a huge fuss over this? And why do we think that this will shift the paradigm for the tech industry as a whole? So as kind of we've already alluded to this, is that generative AI or LLMs can take in a lot of data, like a lot. And they can do so from multiple sources. It's not just text, but it's also going out to the internet and even in video, audio, and images. And what makes them so effective is that it can ingest all of that and then have memory, able to persist tasks and remember what things that it has encountered. And so because of that ability that they can persist things to memory, what they can do is very detailed. They can do very detailed and exhaustive like planning, right? It can go ahead, and that's how it tackles problems, to kind of like decompose or deconstruct a problem to reach a goal. Kind of in order to do that, obviously these AI agents need to be self-learning. So that means that they can take in data, provide an unbiased evaluation of that data. So they don't have like some sort of prejudgment, human prejudgment about like what that data particularly is. And when things do go wrong, and they will, just like a human, when they do go wrong, they can provide an unbiased approach to adjust like how they're attacking a problem. And that's very cool and very interesting. And the other very interesting thing is they can interact with other systems out there. So like additional content databases, and kind of like you're seeing now a lot recently is they can actually make API calls to existing platforms. So think like REST API calls. So it's a very, very cool, like what they can do. So as in terms of use cases, like potential use cases, I don't know if anyone's heard of the service called TaskRabbit, but effectively this is kind of like instead of the human version, TaskRabbit, where you hire someone to go do something for you. These AI agents are effectively like computer-driven TaskRabbits that'll crunch on a problem and provide you with a result. We know these LLMs are great at generating content, accessing APIs, and all sorts of data like audio, video. So I created a whole list of like use cases for particular fields. By no means is this exhaustive. There are hundreds and hundreds of thousands of potential use cases in all sorts of different fields. I'm not going to cover them all the list that I have here, but we all know that they're good for content creation. Probably told ChatGPT to generate something that's kind of creative. It could be anything from a business plan to like a story, but it can generate a blog, but it could potentially be used for, because it has memory, it could be used for forecasting and planning. So think about like having an LLM or this AI agent manage a marketing campaign. So these are like larger tasks that take more time and evolve over time, right? So you could potentially have like an AI agent run a marketing campaign. Another one I'm going to pick here that's kind of interesting is for gaming. This one's a little more accessible because we all know what video games are like, but you could have a video game that is smarter and more adaptable, like opponents that are smarter, depending on the game, whether how they fight you or how they interact with you, change their strategy about like how to defeat you. So it's kind of very interesting what they could do in like a gaming setting. And the other kind of really cool thing I think you could have is video games with increased realism, because you could potentially have an AI that has an adaptive storyline. And so based on how you interact with that storyline, you could have the AI completely give a custom tailored ending to your game. And I think a lot of gaming companies that realize this and integrate these autonomous AI agents into their video games are going to be hugely, wildly successful, because the outcome is going to be different for every person. So having said that, talked about Baby AGI and AutoGPT. So I think the next thing we want to do is we want to go and have a demo for each of them. Let's go ahead and do that. I'm going to share my screen right now. Assume that I've installed all the prerequisites. So first install Baby AGI locally to get that running. So first thing I'm going to do is going to do a git clone on the repo. And then I'm going to go into the Baby AGI clone that I just had created. I'm going to install the requirements. And then the next thing I'm going to do is I'm going to copy the environment example into the environments thing here. I need to make the models directory because it doesn't exist currently. And then I need to copy the transformed model from the previous demo. So the llama model that I had transformed to run on my laptop into the models directory in Baby AGI. So I'm going to go ahead and do that now. Because I want to, instead of using, you can see the LLM model here, instead of running using ChatGPT, I want to actually run this locally. So I need to change this to Llama. So this basically instructs it to run it locally. And then I need to provide the path for Llama, which I'm just going to go down to the bottom here. So we have like an initial task here, or an objective that we want the Baby AGI to tackle. The one that they provide by default is solve world hunger. The initial task list is to develop a task list to solve world hunger. So we're going to leave this as is. This basically is everything configured correctly, so that if you want to now solve for a different task, you change the objective and you change the initial task. So, but we're going to go ahead and stop right there. And then to run Baby AGI with the solve world hunger task, we just need to run the Python script here. So you can see the model's loaded. The first list is to develop a task list. You can see Chroma as the default, which is our memory for Baby AGI. And these are where it's going to store or stuff the tasks for solving world hunger. You can see it's kind of silly because obviously this is an example, but in the solving world hunger example, it says make a sandwich, eat the sandwich, feed the hungry. So basically these are the three subtasks that it had created. Pretty simple task, obviously, and it's kind of like very pie in the sky kind of stuff, but it's kind of just to demonstrate. It takes an initial objective, breaks it down into smaller tasks, and then goes ahead and tries to solve the problem. So very cool. So now that we've looked at Baby AGI, let's take a look at AutoGPT. And we're going to do that by cloning the AutoGPT repo from GitHub. Then go into the directory. And now that we're in the directory, there's kind of a couple of ways of doing this. You can go the Docker path and use Docker Compose to set up all this stuff. I'm not going to do that. I'm going to use the local native scripts that are in there just to kind of like show you like everything that kind of like happens. first thing we're going to do is we're going to set up an environment for us. Then the next thing we're going to do is we're going to activate the environment. And then finally, we're going to just make sure all the prerequisites are met, which they are. And then I'm going to run the example here. So this is basically going to invoke AutoGPT to, effectively accept an initial problem. It's going through all of its dependencies. All right, so this is the final output. It's just kind of giving you some reminders and stuff like that, and warnings, costs inherited from your OpenAI token and the model you use. So just a bunch of warnings here. And now here is the initial task. After you acknowledge it, here's the initial task. And what I'm going to do is I'm going to give it something just kind of interesting. It's not actually we're not going to wait for the answer to this because it's kind of interesting just the way it does, but the task is I want AutoGPT to figure out how to add 1,000 Twitter followers in the next 30 days for me. And so that is the task that I'm going to give it. Create this task like Twitter GPT. It's an assistant to help grow your Twitter followers, and it's got a bunch of goals that are listed here to add 1,000 followers in 30 days. With that, it needs some information. So Twitter GPT thoughts. I need to gather information about your profile. The reason why it needs it is to understand my current situation so that you can tailor recommendations. So this is stuff that it needs in order to figure out who I am. From here, I'm going to provide some input, and it's going to sit there and think about like how it's going to achieve this goal by adding 1,000 Twitter followers. This is probably the only input that you need to provide it initially, because then you need to provide who you are. But other than that, it will go ahead and run off and try to figure out how to add 1,000 Twitter followers in the next 30 days. So very, very cool. So, but this is basically how you can kick off AutoGPT to get this to work on your local system. So I hope you enjoyed the demo for Baby AGI and AutoGPT. I'm just going to provide some resources for everyone who wants to do this stuff at home in the next 3 slides. So you don't need to write all the commands down because I'm providing them right here. So these are effectively the commands that I used in the first demo to set up and install Llama. Then here's the information for Baby AGI setup and installation and how to run the example. And then here's the stuff for AutoGPT. I'm obviously going to provide the slides available at the end of the call once this all gets posted, so you'll be able to copy and paste this off the slide. Some additional resources: the Llama CPP project, the Llama torrent link, in case you want to go ahead and download that through non-official means. Running Llama on your Mac, the Stanford Alpaca paper, and then obviously the repos for Baby AGI and AutoGPT. As always, if you found this interesting, I encourage you to join the Symbol community. Follow us on Twitter and Slack to join the conversation. With that, I'll open up for any kind of questions that you might have. And if there aren't any, you can always reach me afterwards, but thank you for watching the presentation. You can reach me on my socials here, which is just at dvonthenin on LinkedIn and Twitter. And you can find my personal blog there. And thank you very, very much for attending. Hope you found it useful.